So here we go with 21 through 40. The quantum number that designates the orientation of the orbital in space, that's the m quantum number, like -1, 0, 1. So m, that'd be c. Okay, the number of values of L, that determines the number of sublevels. So if n equals 3 and L equals 0 or 1 or 2, there are 3 possible values, that's 3 sublevels. C. If n equaled 4, then L would be 0, 1, 2, or 3. So that'd be 4 sublevels. Like we said a minute ago, there's 4 sublevels in the 4th energy level. All right, when the secondary quantum number is 1, m, so if L equals 1, then m can be -1, 0, or 1. So right here. Over here, L equals 1, again, -1, 0, or 1. So m goes from negative L to positive L. The number of electrons in an F sublevel, the F sublevel is L equals 3, so m equals -3, -2, -1, 0, 1, 2, 3. It's 7 values. Each orbital holds 2 electrons, so the answer is 14. Right, shortest wavelength would be the highest energy. So remember, C is equal to wavelength times frequency. So which one of these is the highest energy? That would be 5s. All right, group 14A, that is group 14, have outer configurations. All right, so on this one, you need to find group 14 on the periodic table. So I'm going to draw a quick table here. There you go. There's your periodic table. So this is column 1. Oops. Oops, I didn't do so good there. All right. All right, so column 1, column 2, all these are transition elements. That's column 13. This is column 14. So column 14 is this one here. This is the 4th tall column. So 1, 2, 3, 4. So they all end in P2, and that's B. Remember the S, this is the S block over here. And this is the P block over here. Whoops. S, P, this is D, and the F's are down here with 14 wide. And that 14 is the second one into the P block, so there are 2 electrons. P2. Okay, irregularities happen either, usually they happen in the D or the F. There's no irregularities in the S and the P. So which one of these elements is in the D sublevel block? Well, there are 2 of them. There's zinc and there's gold. But zinc is in the D10 position, which is right here, right there in that last position. And gold is in D9, and I told you that you wanted to know that there are possible exceptions in D9 and D4. I told you there were a bunch of them, but D9 and D4 are the ones I wanted you to know for sure. Okay, electrons in the outer shell of arsenic. Arsenic's in this next column over here. It's column 15, so there'd be 5 in the outer shell. And when an atom absorbs energy, its energy is going to go up. And it goes up by definite quantities. Remember, you got to have enough energy to climb to the next rung of the ladder or the next energy level. So it's a definite quantity. And of course, when you release the energy, it's the same thing. It decreases. I mean, it's the same idea. You're moving back down now. The electron's coming back toward the nucleus. And you're releasing a certain quantity of energy. And we measure energy by the equation h nu. So the answer is B. It decreases its energy by h nu. That's the equation that we had on the board in the class. And then for an F sublevel, I went through that a minute ago. It's -3, -2, -1, 0, 1, 2, 3. So that'd be 7 different values. E. 32. So for P sublevel, this goes back to our L values. Remember we said I'll just do n equals 3 and L equals 0 or 1 or 2. This one's called S, that one's called P, that one's called D. So the L value is 1. Nitrogen is in column 15 up here on our little periodic table I made. It's in the 15th column. It's got 5 electrons in its outer shell then. It's the 5th tall column. So if it has 5, it's 3 electrons into the P, because it goes 1s2, 2s2, 2p3. It's the third one, so it ends in p3. The one that would be most likely to obey the filling order is the one that is not in the D sublevel. So there's only one of these that's not in a D sublevel. It is magnesium. Now, right now, go back and look at your periodic table. Make sure that you understand that magnesium is in the S block, not in the P block. Okay, since phosphorus is orbital notation, let me show you here, 1s, 2s, 2p, 3s, 3p. These are the orbitals. Remember, the p's have 3, the s has 1, so -1, 0, and 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So how many unpaired electrons are there? There's 3 of them. Same electron configuration. Calcium has 20, and titanium, has 20, and titanium has 22. So if you have a +2 on calcium, it's not 20 anymore, it's 18. Oops. All right, I'm going to have to, I lost my connection to my tablet, so I'll go ahead and do it this way. So that's going to be 18 because of the +2, so 20 minus 2. Chlorine's -1, and neon is, so chlorine -1 means it has 18 electrons, because normally chlorine has 17. Neon has 10, so 18 and 10 are not equal. Sodium normally has 11, and neon normally has 10. The +1 charge means that the sodium has lost an electron, now it has 10, so they're equal. So the answer to 36 is C. Since I'm on a P, there we go, C. I can do it with my cursor. All right, how many pairs of electrons occur in the electron dot diagram of oxygen? Okay, this is hard for me to write with my cursor, and I just lost my pin connection, I think. Oh, no, I didn't. Here, I'm back. All right, so here's electrons configuration for oxygen. 1s2, 2s2, 2p4. All right, there are 6 total electrons in the outer shell, right here. Oops. The outer shell is just this part. Okay, so you have oxygen, you have 2 electrons here, and then 1, 2, 3. Remember, this is the p sublevel. It has 3 orbitals, and then you have a 4th one in the p sublevel right here. So there's your dot diagram. So now how many pairs are there? 2. Here's a pair. There's a pair. So the answer is B. And the answer up here is C. I'll make it neater. All right, and which one do the d electrons never pair up? Well, you know you've got 10 electrons in. I'm going to go ahead and draw the 5 d orbitals. And draw them horizontally. So manganese is in the d5 position. Take a minute to look at your periodic table. Make sure you understand about the d5 position. All right, are you there? So manganese is d5. By the way, if you need a periodic table, there's one on the front page of the website you can pull up. All right, so since it's got 5, it's in the d5 position, they have to go in like that. So there's not a pair of electrons in manganese. Cobalt and nickel and iron and gold are all beyond the d5. They're in the second half of the d sublevel. So they're going to have pairs of electrons. All right, the one having the same S and P configuration for n equals 5 as gallium does for n equals 4. You just look at your periodic table again. So here's that little section of the periodic table. Okay, here's gallium is right here in this spot. Whoops. So GA is right about there, I think. Okay, so you're really looking for the one that's underneath it. It's in the 4th series, so underneath it in the 5th series is indium. So that's E. So they all have the same outer shell arrangement, except that the energy levels are different. So the 5th energy level will be the same as the 4th if for the element that's right underneath gallium. And then 40, the symbol of the element in the fourth series has the same electron dot notation as sodium is. Well, if you look over here on this side of the periodic table, sodium's right here, and potassium's right underneath it, so it's going to be potassium. That's C. All right, so that'll be where I'll stop for part 2.